Welcome back. It's still E.Johnny, your video mathematics tutor. So we've seen the definition of sets in the previous or other videos. We've seen forms of sets. We've also looked at types of numbers as it helps us in describing the elements of a set. Then we've also seen the types of sets explained. In this particular video, we'll be looking at the relationship between sets. Very simple and straightforward. So stay with me. The relationship between sets that we'll be looking at are intersection. Next is union. That is intersection of sets, union of sets. We'll also look at complements of sets. Complement of sets, and we'll also look at difference of sets. So I'm going to quickly run down through this. Okay, let's start with intersection. If I have a set A to be equals to 1, 2, 3, 4, 5, 6, and I have a set B to be equals to say 1, 5, 6, 7, and then I am looking for the intersection of this set. So I'm looking at the first one, the intersection. For intersection of sets, you write it as, you see something like this, a symbol that is like N. So for intersection of these two sets A and B, which is A intersection B, is equals to the element that is common to the both sets is what we call the intersection. Now let's look at set A and B. What is common? 1 is here, 1 is here, you pick 1. 2 is here, but there's no 2, you leave it. 3, no 3. 4, no 4. 5 and 5, you pick 5. 6 is here, 6 is here, you pick 6. So we say that for intersection of sets, there are those elements that are common to set A and also common to set B. That is what we call intersection of sets. So mathematically, we can say that A intersection B is a set of X such that X belongs to set A and X belongs to set B. That is A intersection B. That A intersection B is a set of X such that X belongs to set A and X belongs to set B. That is to say, look at it. The element belongs to set A and also belongs to set B. It also belongs to set A and belongs to set B. Belongs to set A and belongs to set A. So this is a summary. That A intersection B is a set of X such that X belongs to set A. That is to say, that element here it can be seen as 1 or 5 or 6, belongs to set A, and that element also belongs to set B. That is what we mean by intersection of sets. For union of sets, let's look at the union of sets. Union of sets. For union, the symbol is something like this, like U. So if I have two sets A, which is 1, 2, 3, 4, and I have set B to be 1, 3, 5, and 6. If I'm looking for A union B, it is equals to A union B means that the element must belong to set A, or must belong to set B, or must belong to both sets. In other words, inside union, there is intersection. So 1 is here, 1 is here, I'll pick 1. 2 is here, but there is no 2 here, I'll still pick 2. 3 is here, 3 is here, I'll pick 1. 4 is here, no 4, I'll pick 4. There is 5 here, even though there is no 5 here, I'll pick 5. 6 is here, even though there is no 6 here, I'll still pick 6. In other words, in union, you are bringing the element of set A and set B together without repeating the element. In a case where it repeats, you are only picking one, which is in the case of intersection. So we say that the element must belong to set A, like in this case, it must belong to set A, or it must belong to set B, like in this case, or it must belong to both sets, like in this case where there is repetition. So just bring the element of set A and set B together without repeating the element. That is union of sets.